Today's session, we are going to discuss a small problem on center of gravity and moment of inertia. Myself, Bipin Patil, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. Thus, in today's session, we are identifying center of gravity and the moment of inertia point, the centroid of the plane uniform lamina shown in a figure. Let's observe the figure first. This is the rectangle, semicircle, one triangle dimension. The dimensions already it is given. So let's see observe. This is 50 mm. Next one 50 mm. Further, this is 25. The radius dimension, this is 25 mm. Then this is 50 mm. That's all. Now the question is, you may identify the centroid of the plane uniform lamina. My dear friend, whenever you are identifying the centroids, first of all, you may bifurcate the given figure into the number of diagnostics. That is, first one semicircle you may consider, then the rectangles are there, then you may consider the triangle, and then try to identify it. So for example, this is my figure number 1, this is my figure number 2, this is my figure number 3. So the centroid 1, this is for second, this is for third. So you may consider G1, G2, G3 is there. Next, that is a few steps are there. What is your first step? Your first step is, that is nothing but the area calculation. What is your second step? You may identify the reference axis, and by considering the reference axis, calculate the centroidal distances. Then the next one, that is nothing but you may calculate the centroid. Last step is there, that is your centroid. So first of all, you may calculate the area. How to calculate the area? So observe the figure. If I consider this triangle, so the area of first one triangle, that is nothing but figure number 1. So you may consider A1 is there. So very simple step is there, 1/2 base into height. 1/2, that is 0.5 into base is 50 into height is 50. So please do the calculation, try to identify it, and you'll get the area of triangle 1250 mm square. Simultaneously find the area for second figure. This is your A2. Semicircle is there. So area of the semicircle pi r square by 2. So pi into radius is 25 square divided by 2. Do the calculation and try to identify it. So you'll get the area of this semicircle is 981.747 mm square. Simultaneously find the area of this rectangle. How to identify it? So area of third figure, that is A3, is equal to B into D. That is nothing but this total distance 50 and this is 50, so 100, and the depth is 50 is there. So 100 into 50. So you will get 5000 mm square. What is the next step? The next step is you may consider the reference axis. So I am considering the topmost part. This is my reference axis 1 1, and the extreme right hand side part, this is my reference axis 2 2 is there. Why we need this particular reference axis? So to identify the centroidal distances. So now from reference axis 2 2 you may identify x1, x2, x3. From reference axis 1 1 you may identify y1, y2, y3. What do you mean by x1, x2, x3? What do you mean by y1, y2, y3? x1, x2, x3. These are nothing but the horizontal distances from reference axis 2 to small g1, g2 and g3. Similarly, you may consider y1, y2, y3 is nothing but the vertical distance from reference axis 1 1 to g1, g2 and g3 is there. So let's you observe, this is my y1, this is nothing but y2, and you may consider from here to the center, this is nothing but y3 is there. x1, x2, x3, the small distance, this is your x1. From here, this is your x2, and the last one, the small distance, this is your x3. So let's you calculate the x1, x2, x3. Simultaneously you may calculate y1, y2 and last one, that is nothing but your y3. How to calculate it? x1 is nothing but the small distance, and already they are given, this is 25. So because this is total 50 and the centroid lies here, so half of this you will get 50 by 2, that is nothing but 25 mm. What do you mean by x2? x2 is nothing but this total distance. How to calculate it? Total is, you may observe here, 50 plus 50, 100 plus 25, 125, 125 minus, now I need this total distance, or you may identify in a separate way. This total is, you may consider, this is your 100. Okay, so this is your 100 plus this small distance for semicircle, this is 4r upon 3 pi. So this is 4r upon 3 pi. So put the value, 4 into r is 25 divided by 3 pi plus 100. So after calculation you will get 110.610 mm is there. 110.610 mm is there. Next, you may consider y1, y2 and y3. How to identify it? So y1, this is the small distance. How to calculate this particular y1? So if I consider triangle, so this is base, this is your toe, this is your toe, this is your base. So from toe it is 2/3 of the span, and span is 50. So y1 you may consider 2/3 of the span is 50. Another one dimension is remain, that is x3. X3 is half of this, so that is nothing but 50 is there. And y1, how to calculate the y1? 2/3 of the span, so 2/3 of the 50, you will get 33.33 mm. Now the next y2. Y2 is nothing but this vertical distance. So already this is 50. This is 50. And the next one, now I require this distance. So 50 plus 25, you will get 75. So this is your 75 mm. Simultaneously, you may consider y3 is also exactly over the same plane. So from reference axis 1 1, you will get the same distance. This is 50 plus half of this 25, you will get exactly 75 is there. So this is 75 mm is there. So my dear friends, let's you observe here. We have calculated by considering your figure. First one, the area of all the figures. Second one, we have considered the reference axis, and from that we have calculated the centroidal distances. What is your next step? Your next step is you may calculate the centroid, that is x bar and y bar. So how to calculate it? So let's see, observe. To calculate the x bar and y bar, we need a formula. X bar is equal to a1 x1 plus a2 x2 plus a3 x3 divided by total area, that is a1 plus a2 plus a3 is there. So already we have calculated the a1. Area of figure 1 is 1250 into the value of x1 is 25 plus a2, area of second figure, that is 981.747 into x2, that is 110.610 plus a3 x3, that is a3 is nothing but your 5000 into x3, that is 50 is there, divided by total area. So a1 plus a2 plus a3, 7231.747 is there. So please do the calculation and try to identify the value of x bar. You will get the value of x bar, that is 53.906 mm. This is from right hand side, that is you may consider the reference axis we have considered. So this is your reference axis from 2 to is there. Now simultaneously you may identify the y bar. How to calculate the y bar? So the formula is same. Y bar is equal to a1, instead of x1 you may consider y1, a1 y1 plus a2 y2 plus a3 y3 divided by total area. So a1 is same 1250 into y1 is 33.33 plus a2 y2, area of second figure 981.747 into y2 is 75 plus a3 5000 into y3 is 75 divided by, you may consider the total area 7231.747. So if I calculate all these particular things, you will get the y bar, which is from top, that is the reference axis 1 67.797 mm. This is from top. Top is nothing but you may consider from the reference axis 1 1. So we'll get the centroid of the three figures directly, that is by considering the area of all these figures and the centroidal distances. So likewise, easily you may calculate the centroids for given figure by considering this particular methodology. So these are the references. Thank you.